All right, I guess I'm recording. Yes, because I turned the sound off. I didn't hear the little buzzer. Okay. All right. So I'm going to, so you guys have an assignment scheduled for 10 a.m. today on more empirical molecular formulas. So number 3, number 4, number 5 will be due tomorrow before class. We'll go over it tomorrow in class. Also, I attached this. So 6, 7, and 8. Feel free, because you're going to each of you get a copy of this. Feel free to just add another page to this and put 4, 5, or 3, 4, 5 right in this doc, and then just submit or turn all of them in together. I wrote that in the directions. All right. So, anyways, this should be less than 10 minutes. I'm going to show you. Let's see. Let's go with green today. I'm going to show you how to do the problems that are due today. All right. So let's see. So first one here. If I said we have an unknown compound, and the compound contains 1.2% carbon and 14% Cl. So now the other day we did some problems where I gave you the mass of these elements. You had to convert them to moles, divide by the lowest number to get the empirical. This is very similar. So an unknown compound, containing 1.2% C, 14% Cl by mass. Meaning the entire mass of this compound, 1.2% of it is carbon and 14% of it is Cl. All right, so by mass. So the question would be calculate, probably determine the empirical formula. Okay. Determine the empirical formula. All right. So these are just like the ones we did last time, except I gave you grams here instead of percentages. So percentages sometimes give kids anxiety, but this is actually pretty easy. All you do is you say, all right, well, if this is 1.2% and this is 14%, because we can assume we have, let's say, 100 grams of this stuff, we can actually just turn the 1.2 into grams and the 14 into grams. So in Regents Chem, basically, I just say, all right, take the percents, turn it to grams. So you have 1.2 grams of carbon and 14 grams of Cl. And again, why can you do that? Because if you know the percentage and it doesn't give you a specific amount of the compound, we can just make up the fact that we have 100 grams. So if we have 100 grams, then I know 1.2% is 1.2 grams and 14% is 14 grams. But again, in Regents, bottom line is you're just going to ignore the percents, make them grams. Why is that helpful? Now we can convert those to moles. So we know for carbon, there's 12 grams in 1 mole. All right, that's the molar mass, the gram form of the mass from the periodic table. I'm not going to show you that. You got to know that at this point. We have 1.2 grams. How many moles of carbon is that equivalent to? We do the same thing with Cl. Cl on the periodic table has a mass of 35 grams per mole, the gram form of the mass. We have 14 grams. How many moles is that equivalent to? So we cross multiply and divide. X equals 0.1 mole of carbon. Over here, cross multiply, divide. X equals 0.4 moles of Cl. So if I divide 14 by 35, it's 0.4. If I divide 1.2 by 12, it's 0.1. If I divide by 0.1, right, divide by the lowest number. Out of these two, 0.1 and 0.4, 0.1's lower, so divide by the lower number. Divide by 0.1. So 0.1 divided by 0.1, that's 1 atom of carbon. 0.4 divided by 0.1 is 4 atoms of Cl. So the answer to this question is C1, Cl4. Except we don't really put ones, right? Here, let me rewrite the whole thing. So it's just C CCl4. That is the answer to this question. Now, on the worksheet due tomorrow, you're going to do something very similar to this. Then I'm going to say, all right, well, you know the empirical formula is CCl4. The next question, all right, let me hear. This would be easier. So we know the empirical formula is CCl4. That's the simplest whole number ratio, 1 to 4. Okay. What if the next question said, determine the molecular formula of this compound, of this one here, this compound. So there's the empirical. I want to know the molecular of this compound if the formula mass, meaning the mass of the formula, of the mass of the molecular compound, the molecular formula. So the mass of this compound we're going to determine is, give me a second, I actually didn't write this down. (304 grams per mole). So basically what we're going to do here is we're going to say, all right, I know my empirical is CCl4. Oh, what am I doing? CCl4. I know that. My molecular is going to be CXCl. So I'm trying to figure out these new subscripts. I know the empirical is 1 to 4 ratio. The molecular, as we learned before, is a bigger version of this, and it's the same proportion. In other words, if this is 1 to 4, this one's going to be 2 to 8, or 3 to 12, or 4 to 16. So if I multiply this by 2, that could be an answer. If I multiply this by 3, or if I multiply these subscripts by some number, whole number, 2, 3, 4, 5, whatever, that gives me the subscripts over here. Now, why does that work out? Here's why. If I take 1 carbon and 4 Cl's and I add that together, 1 carbon and 4 Cl's. So Cl is 35, so it's 4 times 35, and then 1 times 12. 4 times 35, that's the mass of each Cl, and 1 times 12. 35 times 4 is 140, plus 12, that's 152 grams per mole. I know this here is 304. Question told me that. So my empirical is 152. Again, how did I do that? Well, I took my answer from the last question, this compound here, and I multiplied 4 by 35 and then 1 by 12, add them together. All right, so I add these together and I get 152. So I know this compound's larger. How many times larger? I just divide these. So 304 divided by 152, 304 divided by 152. I did something wrong. Sorry, guys. I just did this ahead of time, so I wouldn't make a mistake. I think this is wrong. 4 times 35. No, then this is wrong. This number's wrong. Sorry, guys. I don't know where I came up with that number. Sorry, this number's wrong. So that's not cool. All right. So give me 1 second here. No, that is right. What? Sorry, guys. I'm like having a moment here while I'm recording. Yeah, that was right. I don't know what I just did. So, anyways, forget that little segue there. I'm sorry. So, everything was correct. The molecular formula is 304 grams per mole. Why? The problem gave us that. So, the problem would have to always give you that number. So, again, what we do is we find the mass of the empirical, 152. And if we know the empirical is 152 and we know the molecular is 304, this number is 2 times larger than 152. So 304 is 2 times larger than 152, meaning this compound here is 2 times larger than that. So if we multiply it by 2, that equals C2Cl8. There is the molecular formula. And to double check yourself, you could do 8 times 35 plus 24 for the two of those, and you get 304. Now I made this one up. This is a real compound. All right, but just to show you how to do these problems, I just kind of made this up. So this compound I've never seen, but that's kind of irrelevant a little bit. I just want you to learn the process here. So again, molecular formulas are always some whole number factor meaning times 2 times 3, bigger than the empirical. All right, so you're going to have those two types of problems on the worksheet due tomorrow, worksheets. And the last thing here, I'm going to show you another example of that, especially because I kind of paused there and thought I made a mistake. Here's another example. If I give you a empirical formula, CH2, and I want to know what is the molecular formula. All right, what is the molecular formula? So there's the empirical. If formula mass is, this one I have ready to go, or not. I had it written down earlier. 80 grams per mole. Okay, so again, if we have an empirical of CH4 and the molecular formula they want to know, and we know the molecular formula, we know the molecular formula has a mass of 80. We do the same thing we just did on the other problem. CH4, this is 12, this is 4, so that's 16 grams per mole. I want to know X and Y. So I'm multiplying this by some whole number. Well, how do I figure that out? Well, this has a mass of 80 grams per mole. So I can divide these numbers, 80 by 16, I get 5. So this compound is 5 times bigger than this. So CH4 times 5 becomes C5H20. C5H20. And again, you can double check. 5 times 12 is 70 or 60. 5 times 12 is 60 plus 20. And that gives me 80 grams per mole. So on the worksheet due tomorrow, worksheets, if I give you an empirical and they're asking for molecular and they give you the mass, you just have to find the mass of the empirical, doing some simple math. When you divide those two masses, it'll give you a whole number, and that's the number you multiply the empirical formula by, because that's how much larger the molecular is, right? That's really messy. What else is new? C5H20. It's a little better. All right. So hopefully that helps. I'll post this with the assignment. Hope you guys are doing well. And I'll see you tomorrow.